Okay, so far we've talked about primitive types like integers. You say int number equals 15. We say double double fraction equals 1.5. Uh, char, you say symbol equal equals yeah, let's go with the dollar sign, and we say so these are primitive types, inbuilt primitive types, or even a more complex type of string, uh, pet name equal let's say Bruno. But these are all these are primitive types, and this is an inbuilt type. Okay, meaning they're built into the C sharp programming language and serve very specific purposes. They come with their own set of methods and properties, as we've previously discussed. So, for example, let's say this int number. Okay, we say if we put number dots and we see a whole bunch of methods, functions that come together that are tied to the integer type. Sorry, integer primitive type, like compared to equals get hash code and the rest. And if we do something like pet name, which is a string, dots, then we see a different set of methods coming together. Okay, that are tied to the string, to strings. But check this out. Regardless of how new you are to programming, regardless of how new you are to programming or C sharp in general, surely you've seen something like this: class, person, and you have string first name, string last name, int age, and double weight, something like this. Well, what I've just created is a custom type or object named person using the class as a blueprint. Inside the person object, we have properties. Okay, so first and last name are both are string objects, which is a collection of char arrays. If you watch my previous videos about strings, okay, and the underlying meaning in strings in programming in general, and age over here is an integer, which is simply a system dot int 32. That 32 means 32 bits in size. And finally, we have this weight, which is a fraction, which is double are 64 bits in size. C sharp custom types allow you to define your own data structures and behaviors beyond the primitive built-in types. Basically, you are mapping data and behavior specific to your own application. So, if you create a person app, depends on what type of application you use, that you would need um, information on that person. Handlers, maybe credit score, those sort of things. You get the idea. There are six custom types in C sharp, which are classes, structs, records, enums. There is also uh, interfaces and delegates. Delegates. Okay, these are the types of custom types in C sharp that can be used to create objects of your choosing. Now, we're not gonna do any of this. So let's just go ahead and delete it. We won't be talking about interfaces or delegates today, as they are part of bigger topics I will cover soon. I just want us to focus more on the concept of custom types. So let's start with classes. Um, let's start with classes, and you can see here we've already touched a little on classes. Our person class. A class is the most common type, is the most custom, is the most common custom type in C sharp. Classes are reference types, meaning they are allocated on the heap with a reference on the stack. They serve as a blueprint for creating objects, as you can see here. Classes define the data. Classes defines the data, also known as fields. These are fields or properties. Name, age, weight. These are properties. Properties that hold data. To declare a class, you just need to use the class keyword here. Okay, followed by the name, which is this person, and the body. The body is what's inside these curly braces. This is the body of the class. Okay. Access modifiers can be added. Access for modifiers can be added first. So you can say public. Okay. To control the accessibility of said classes. I'll cover that in a future video. Why you need to control access, and the benefits of doing that. But if you don't add a modifier like this at all, and you just say class, well, it automatically defaults to private. So this class person is the same thing as saying private. What in the world? Private class person. This is the same thing as saying this, but we're gonna make it public because I'm gonna try to access this to show you the example that I'm talking about. So after we create our class object, we can now create, this is the blueprint, we can now create a new person. Okay, so let's go ahead and do that. Let's delete this, and we say person equal dude. Let's call him dude equals new person. Okay, then we do this. We say first name equals Frank, comma, and we see that it's inaccessible due to its protection level, and that is because we need to add public. Okay, we need to make the properties public like this. And so now that squiggly line is gone, and we say, let's put a semicolon at the end here. So we say Frank last name. You see, now we even get IntelliSense, Sinatra. Okay, and we say age. Let's call him 60 years old, and weight 180 pounds, 80.5 pounds. Okay, this is an American way of saying it, of course. And now in console right line, we can come down here and say, we put the $sign and say dude dot first name. Okay, then we come here and say space dude dot last name space dude dot age, and finally dude dot weight. Okay, and so let's go ahead and run this and say, hopefully this runs without any problems. Okay, wow, this simple thing. Warning, because this could be null, but don't worry about that. It's not an error, it's just a warning. In a real application, you shouldn't do this. And we see Frank Sinatra, age 60, 180.5 pounds. We've created a new object, a new person based on this blueprint. These are the information we want. We can simplify this a lot further using a constructor. So we come back to this object here and we say, we come here and we say public. A constructor is a special type of method that has the same name as the name of the object. F name, okay, which signifies string L name, int small letter age, and double small letter weight. Okay. Now we can do first name equals f name. We say last name equal L name. We say age equal age, and we say weight equal weight. Okay. And what this means, now is that we can just do this. And we just say Frank, not Frankie, Frank Sinatra 60 180.5. Let's see. And if we run this here, hopefully it does it again. And we get the same response because of this method, this constructor that we created here. So anyways, classes can hold behaviors. Classes can also hold behaviors too. When I say behavior, I just mean methods, okay, or functions. You know how we have methods that map to ints, as I showed you earlier here when I showed you the dot, using the dot accessor to show you the methods in integers and strings. Well, those are for the built-in types. Well, you can create. Wait, here, let me just redo what I was talking about in case you forgot. String name Daniel. Okay, and you can say name dots. You can say, hang on. Let's call this upper, and we say name dots to upper, for example. You see, that's a method that's attached to strings, and we have If we hover over it, it returns a copy of the string converted to uppercase, just like that. We can create our own behavior. This is called a behavior. This, well, it's a method, but you can also refer to it as a behavior. We can create our own custom behavior, just like we can create our custom classes. We can create our custom behaviors that come with those classes. Okay, so we come back here and we say public void full name, and then we say, we open curly braces here and we say console dot write line, and then we come in here and we say full name first name, we give it a little space, last name. Okay, so let's go ahead and get rid of this. And if we come back here and we say, let's get rid of this, and we just say this right, this dude dot full name. See, it actually recognizes that method that we created. And if we run this here, we say .NET. First of all, let's build it to make sure nothing is bad. And then we say .NET run, and we get full name Frank Sinatra. Just like that. Perfect, isn't it? So this is a method attached to this class. This is a custom method attached to this custom class object, which uses class as a blueprint. So let's summarize classes. Classes are reference types, as I said, meaning they are stored on the heap with a stack reference that points to them on the stack. Classes are the most common way to define custom types in C# because they are suitable for larger data structures. Okay, as you can see, as we kept going and going and going, this class got bigger and bigger and bigger and bigger. We put a constructor, we put a method. In a real world project, this could have as much as 10 or 15 properties, and you can have 3 or 4 methods. Okay, so classes are they are the most common type and best. Actually, that's why they're the most common, because they're the best for larger data structures. Okay, passing them around involves copying only the reference, not the entire data. Okay, classes are flexible because they can model complex objects with state and behavior, as we see. Okay, behavior is the method. In other words, real world entities that have both data properties and actions. Okay, example, we already, this person, but we can say public car, for example, class car. Okay, and you can have things like number of tires, tire number, things like that. You get the idea. Or it could be order. Okay, maybe the order in which you create, like an order list from Walmart or whatever grocery store that you want. When you use those apps, the apps that I'm talking about, grocery delivery apps. Okay, classes support inheritance. You can create a hierarchy of types where derived classes inherit from base classes. So, for example, this class person, you can create a new class here that inherits from class. You say class man person that inherits from person, and then you say public void dude stuff. you get, you get the idea. Console dot write line. I don't know. Talk about Jason Bourne. Guy stuff. Guy stuff. Anyways, don't worry about this for now. So this class man will not only be able to do this dude stuff, but will also inherit things like full name, methods from person like full name, and it will inherit all this. So a man, of course, is expected to have first name, last name, age, and weight, and things like that. This man class will also have every single one of those things. Classes are mutable, meaning the data is expected to change after its creation. You can change your name, and as time goes on, your age goes up as well. So, we're done talking about classes. Next up, let's talk about structs. Okay. Structs, which stands for, this just stands for structure. Okay. Structures are value types, meaning variables of a struct type directly contains their data value on the stack. Because structs are assigned directly on the stack, they tend to be very fast. Struct syntax is it's very similar to classes. So when you say public struct points, this is always the most popular points, isn't it? Okay. The difference is that rather than class here, you have points. You need to be very careful though when using structs. First, structs don't support inheritance. So you know how I inherited uh, the from person when I created the man class. You don't. So there's that. You can't inherit. Um, struct doesn't. And it says it's not an interface. Okay, it doesn't accept. Anyways, yeah, it doesn't accept inheritance. Structs don't do inheritance. But there's an even bigger issue. You see, because they are assigned on the stack, when you assign a struct to a new variable or pass it to a method, a copy of the entire data is made. So unlike classes, so structs. That's why generally your struct should be very small. If you watch my video on primitive types as well, you would know this. But structs, you need they need to be as small as possible, no more than 64 bits, I believe. Okay, when you copy anything, so we say public int x get set. Okay, public int y get set. If you make a copy of this, okay, it's going to copy the entire data and make a new copy. Okay. This means the structs are only suitable, as I said, for small data structures. The general rule is nothing more than 64 bits. This is why when you Google struct on C sharp or any other programming, most program, at least to my knowledge, typically you get an example that looks like this. Okay, because integer is what, 632. You see, 32 bits. So together this is 64 bits. Okay, here you can see an example with total of 64 bit. So you need to be very careful about using structs. Just use it for only very limited things, uh, uh, small things. Um, so let's summarize structs. Structs are generally a value type. You can, however, structs can be a reference type if they are stored on the heap. On the heap, when they are part of a class, you can have a struct related to a class that is stored on the heap. Okay, structs are generally immutable by default. They are often designed mutable by default. They are often designed to be immutable, especially when passed as an argument. Okay, remember when I said copying a struct results in copying the entire value? Well, that's good because then there are no side effects. They should be used when performance is critical. Okay, structs offer better performance due to less overhead in memory allocation based because of it's generally stored on the stack. So it's just there. It doesn't have to go look on the heap. Okay. When allocated on the stack, there's no need for garbage collection. So that's the second reason. Getting information from the stack is it's very fast, but also once you use it, it pops. If you know anything about heap and stack and data allocations, then you know once you use it, then it's gone. No need for garbage collection. Okay, making them perfect for small, frequently used types. In fact, the primitive types in C sharps are structs. Did you know that? So okay, these integers. Right. If you hover over this, you'll see read-only struct. And in fact, let's see if we can go to the definition. Struct int 32. We can see read-only struct. It is in fact a struct. So your ints, your integers, your doubles, your char, things like that, they are all actually structs. Same with bytes, s bytes, short, float, you get the idea. So next, let's talk about records. Okay, public records. Records are relatively new types introduced in C Sharp 9. I mean, I say relatively new because, I mean, that was in 2020. So, 5 years ago. But C Sharp is 25 years old. So, what, 2000? Yeah, I think it's 2000 C Sharp came out. So, yeah, newish. Records kind of look like classes, but their purpose is to reinforce immutability and value based objects. What is value based object? A value object is an object that is defined by its properties rather than a unique identity. Basically, unlike an object with a unique ID to separate them, value objects are immutable and primarily used to encapsulate small pieces of domain logic. Equality by value rather than equality by ID. So generally, when you make an application and you have something like public class, let's use person. What's the harm? Okay. Usually in an application, you will have something like this: public GUID ID get sets. And this is how you would recognize this specific person. Each person has a unique ID. If it's a GUID, if it's an int. It could be an int, but usually in a real world application we use GUIDs. Um, so we records are for things that don't particularly have a unique ID. When so yeah, let me, rather than keep talking, keep yapping, let me just show you a good example. Let's say we are creating money. Okay, so money is something that works, and we know it's very important. Of course, imagine messing up people's money. Imagine creating an app where the money is not what it seems, and you could get in serious trouble during payments, and you get the idea. So we have I equatable. If you want to represent money in in with a class, you would say something like this. Okay, then you say public decimal amount, and you get sets. Okay, and then we'll say public string currency gets sets. So now we have to, so let's go ahead and do our, our constructor. We say string currency, and we say amount amounts equal amounts, and you say currency equal currency, standard constructor. Now we have to say this is when we need the equality. So we say public, because we're using class, we need to make sure that the money, the current, because if you think about it, different nations have different currencies, and all those currencies have different values, which is why it's very important to make this as strict as possible. $100 is not the same thing as £100, or €100, or yuans, or you get the idea. And we say public bool equals money question mark object. Okay, now we need to ensure that this is as equal as possible. And we say if object is not money other, okay, return false, then it's not equal. So if it's not, this is casting, if the object that we're passing in is not of object money, it's not of type money, then just return false immediately. Otherwise, return amount equal other dots amount. So the money has to be, the amount you're passing in has to be the same amount as the default, and the currency has to equal other dot currency. This is critical. Okay, so this is the first thing you have to do to make sure that, because this money doesn't have a unique identifier, all we know is amount and currency. So we need to make sure it's equal at all time and it's in a valid equal state. Next up, we say public override int get hash code. See, it even returned it for me, and it says, let's go ahead and say hash code dot combine. amount, currency. Okay, so let me explain. Let me explain what this, if you're new to programming, what this is. Okay, equals and this equals and hash code. All right, equals. If you're comparing to money, if you're comparing money, if the money you're comparing isn't of type money, then don't bother going forward. Okay, return false. If it's a different type. If it is, however, money, then check to make sure that the amount is equal to the amount that you're. If it, however, the money, if it is, however, money, then check to make sure that the amount and the currency are exactly the same. Okay, if they are, then it's true. Bool. Remember, this is bool. It's either equal or not equal. Basically. Now the get hash code. Get hash code is an efficient way to look up hash-based collections. It works with equals method. Okay, so with this equals method, if two objects are considered equal, then their hash codes should also be the same. Well, let's actually see this in action. Okay, don't worry, this everything I'm saying will make sense soon to you. So we say var money 1 equals a new money 100 and USD. So this is US United States dollar. Okay, var money 2 equal new money. Let's give it the same thing. USD. Okay, this should return true. So let's go ahead and see, make sure our method works right. Right line, money 1 dot equals money 2. If this is equal, run, it should tell us true. True. You see that? True. Because $100 US, true. Okay. Now let's say, let's change the first one from USD, which is United States dollar, to CAD, which is Canadian dollar. And we say .NET run, and it should give us false. Okay, because as you can see, it says false because 100, even though they're both 100, they have different currencies because 100 US dollar is not exactly 100 Canadian dollar. And so the properties don't match. So why bother? Why does this matter when we're talking about records? Well, because records are perfect for implementing value objects. So if we were to change our class, this class over here, you see, because we have to inherit from I-equatable, okay, let's hover over this, define a generalized method that a value type or class implements to create a type-specific method for determining equality of instances, okay? If we were to change this to record class, we have to do it this way if we're using a class. But if we were to change it to record, and we see everything kind of looks good, but now the equal sign is screaming at us. So what does it say? It says money.equal must allow overriding. Okay, we no longer need this. We no longer need these methods. So let's go ahead and just, for now, let's just comment them out. The reason why we don't need this anymore, you know what, let's just go ahead and delete it, is because we have built-in semantics. Records are value-based types by default. No need, value-based, not value-based types. They're not on the stack. They are on the heap, but they are value-based regardless. No need to implement equatable, this right here. No need to implement equatable, equals, or get hash code or equality operators. The compiler generates all these for you automatically. All those things that I removed are generated once you use record automatically. That's the beauty of it. So, summary of records. Use records when you want to enforce equality of value. Equality of value objects. Money, of course, is a good example. Another one is address. Okay? I mean, could you imagine charging your customers more or less than they actually required? Or maybe sending packages to the wrong address? You can pretty much see how important these things are in the real world. This means records are actually safer by default, less boilerplates, because you don't need these methods, like the methods that I just removed. Records are immutable by default, making them perfect as DTOs, which stands for Data Transfer Objects. Mapping, when you're trying to map an object being retrieved from a database to users, record-like classes are also reference types, meaning they are stored on the heap with a reference to the stack. Records provide a more compact way to declare data-centric types compared to classes. Check this. Check this. Check this out. Okay, so let's say, let's get rid of this. Okay, so we say record product. Let's change this to products. Okay. Okay, we say public string name sets, and when we can say public decimal price get set. This is actually when I say records have a compact way to declare data-centric types compared to classes, this is the exact same thing as doing, you can do this with records. Products. And we say string name and decimal price. Oh, no comma. Comma. Now the only reason you're getting a squiggly here is because we already have. Okay, so you see, it works, no errors. Okay, perfect. So you can declare it this way or this way. This is much more compact and straightforward, and it's both. This and this are exactly the same. This is more for more to make it look more like a class. But if you want just a simple, straightforward DTO, data transfer object, this makes more sense. Okay, so we're done with summarizing records. Finally, final type of custom where we'll be talking about. Now remember, we still didn't talk about interfaces and delegates, but that's for a future video. Okay? The final type of custom user defined type we'll be talking about today is enum, right here. Enum. Okay? Enum stands for enumeration. Enums are a special set of named constants. Okay, so let's go ahead and remove this, and we say enum. When we say named constants, they allow, what it means is they allow us to give meaningful. Well, you know what? Let's just go ahead and days of week. Okay, so we say Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. And so days of the week, they allow us to give meaningful names to integral values. A simple enum declaration provides a list of names, of named values. Okay, by default, the underlying type is actually an integer. So something people might not realize when they create enums is that this is actually a number. You see, when we hover, it says 0, 1, 2, 3, 4. Well, why is it doing that? Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Oh yeah, right. Because it starts at 0. Remember, computers start counting at 0. Okay, so this is 0. This is actually 0, and this is actually 1. You know that already, because if you hover over it, you'll actually see. Okay, and so now we can say something like days of the week today equal days dots um, Monday. Okay, right line, and you say today is Monday. And if we do this and we say .net, well, let's clear the screen. .net run. Remember, you have to actually save the file before you run it, and it says Monday, okay, because we called Monday. If we say Tuesday, it will say Tuesday. If we say Saturday, it will say Saturday, and so forth, and so on. You get the idea. In fact, we can say, we can also say, we can remember the default behavior is integers, so we can say, um, int numeric value equals, we cast it to today. Okay, and it says, and then we can say, so if we don't want the numeric value for today, so if we're trying to actually then we come here and we put in the $sign like this. If we want to actually find the number there, the numeric value for Monday is 1. And if you hover over here, you see it's 1. Just as we said, okay? The numbers are 0, 1, 2, and their default behavior is 0 to whatever number of enumerations that you have, and they are of the type int. You can now, here's the cool thing that you can do with enums. You can explicitly assign values to enum members. This is useful when numeric values have specific importance, or if they don't start, if you don't want it to start from 0. So you can customize this to whatever serves you. So let's go ahead and remove this. We don't need this. So when it makes sense, you can do something like, let's say we were talking about HTTP codes, okay, which you should be familiar with. Success equals a code of 200, okay. Not found is, of course, what you know, error 404. And server, oh no, these are not semicolons, these are commas. Server errors are 5. Sorry guys, this is a new laptop that I'm trying to get used to, and it has those small compact keyboards. I haven't used those in a long time. um Now, not only can you assign a specific number, you can, so this makes more sense, error 404, not found, error 500. These are real world things, okay, that are used. If you know what HTTPS is, this is how your browser connects to you, talks to you, and you've at least seen, you at least know what error 404 is. So not only can you assign the specific number, so we overrode it from 0. If we put nothing here, it would be 0. Okay. Not only can you assign the specific number, you can specify the underlying type. Okay. The default underlying type of an enum is int. This shouldn't be. This should be something like this. Status code. Sorry, excuse me. Um, but you can we can actually change it. This is integers. By default, they are integers. Then we say we can decide different types of enumerations. Let's say, let's just call it value. Okay. By default, this is uh, alpha 1, beta 2, uh, gamma 3. Okay. By default, this inherits from int. This is actually the default. Okay. Sometimes you need more than just numbers, because a single fixed value uh, won't be enough. So for example, okay, before we get there, we can change this to, this is the default. We can say bytes, or s bytes, or short, and so on and so forth, or long, different data types depending on what you need. Okay. Sometimes when more than just you need more than just sometimes when you need more than just numbers, because a single fixed value wouldn't be enough. That's when flags come into play. So we can add flags to your enums. Okay. That's when you can use flags attributes. They can be very useful. You can combine flags with bitwise operations for a more verbose need. So let's look at a security example. Okay. You say file. Let's say we're trying to lock down file access, and we have none. When you have no file, none. Okay. And you say read 1, and we say write 2. Okay. And I say execute 3. Okay. Um. we can combine this flag is important because now it indicates new that can be treated as a bit field. Okay, and so we say file access. I would say permissions equal file access.read, or because this is bitwise, we're not going to be doing double like this. We'll just say one, or file access.write. Then we say console.write line combined permissions okay. See, so now we can say .NET run. Okay, now we can say oh yeah, spelling error. I thought I was going insane. Anyways, so let's go ahead and run this. Okay, combine permissions executes. So if you can read and write, then executes. Can read is true. All right. The flag attribute tells the compiler that the enum can be treated as a set of flags, also called bit fields. Okay, this one has more to do bitwise. I probably shouldn't have used this example. We'll talk more about bitwise operators down the line. It is a big topic that's not just C sharp, more popular in C and C++, anyways. So yeah, you can combine multiple. You use flags to combine multiple enum options, enum values. Okay. Here's something else you should know. You can actually convert enums to strings. So let's say, for example, we have this enum called color. Okay, and we have red, green, blue, yellow. Okay, we can say string inputs equal green. Okay, and you say if enum dot try parse excuse me color input out color parsed color. Console.write line parse color parsed color. Okay, so we're just going to make sure that whatever input we put in here is part of the enum color. So we say .NET run parse color green. Okay, because now if it's not, then we say else console dot write line invalid color. So if I say, so let's say I say the color here is indigo or whatever, then and we try to run it, .NET run, and it says invalid color because indigo is not part of this. But in order to find out, we need to first parse the color as a string. Okay, so we need to parse this string into to be able to be able to match one of these values. Okay, so that's why we needed the enum.try parse. So we can parse it, and if the name, if the string inputs that we put in equals one of these, then it'll give us the color. You get what I'm saying. Here, the enum try parse enables converting a string safely. Okay, it's a safe way to convert it into an enum value while handling invalid inputs gracefully. We can also convert and iterate over all defined enum values. So we say for each color in enum dot get values type of color, no, capital. Okay, and then we say console dot write line color. Okay, so let's make sure this works. Okay, it does. .NET run, and it tells us red, green, blue, yellow. Okay, so not only can we parse strings to compare enum values, but we can also convert the enum values. So we see red here, which is 0, but we can parse it out as a string here, red, using the enum.getValues. Okay, so let's summarize enums. Enums prevent invalid values by restricting variables to the defined set of constants, thereby enforcing type safety. Okay, so things like days of the week, you don't want a user to be able to put in Taco Tuesday or Taco or the day of Mercury or whatever. You use enums when you want users to only input a very specific type, very specific set of types. Like in this case now we have colors, okay? Red, green, blue, yellow. This is all I want users to be able to choose from. Okay, you use enums when you want users to choose from a very specific, already predetermined type. And something like days of the week, for example, which we used at the beginning of this talking about enums, is perfect. Okay, now next point is when you really break it down, enums are about code readability because they replace numerical literals with descriptive names. So you see, this is actually 0, 1, 2, 3, but we can put red because this is what humans actually understand, and so it helps with readability. Okay, and finally, use flag attributes when combinations of values are required, and also remember to define a non-value for clarity. Okay, so you start with none. Actually, this is a good way to write it. Okay, when using enums. And that's it. That's it, really. We've talked about everything here. We've talked about, in conclusion, we discussed 4 types of user-defined types in C#. Um, We talked about classes, structure, records, and enums. Okay. Uh, so let's talk about it again. Let's summarize it again. Classes are reference types, heap allocated. They support inheritance, base classes, abstract classes, and interfaces. They allow mutability, so field properties can change. By default, class are identity based. Uh, Classes have identity based equality, meaning it compares references, not content. Okay. Use classes when you require a complex object behavior. These are all things that I've talked about. So methods, events, things like that. I don't know who's using events, but okay. Use classes when you're dealing with large data models. Okay, customers, order, things that have constructors, methods, encapsulation, many properties. Also, use classes when dealing with hierarchy structures. So let's do this. So so we say public class vehicle. Okay. All right. So then you can say, when you're dealing with hierarchies like this, then you can say public class car, which inherits from vehicle. And then you can say public, oh, Jesus, public class, what type of car? Maybe an electric car, which inherits from car. You see, when you're dealing with inheritance like this, use classes, okay? To object composition hierarchy. So something like, so this is simple inheritance, but let's say something like public. This is much more complicated, by the way. Employee, okay? And we say um, public string full name get set. All right. And then you say public class department departments. Then you say something like this: public list of employees. Okay, employees. So where this right here is called object composition hierarchy. So this class takes in, this department takes in a list of employees, which is a different whole class, which is exactly uh, um, how real world applications work. So think of something like Facebook. When you have a class of a person, then you could have a list of friends, like a friends list or a follower list, and there are other people as well. A list of, rather than employees, it could be friend lists, friend requests, or followers, or messages from other people, things like that. So when you're talking about modeling real world applications, use classes. Next up is structs. Structs are value types, meaning variables of a struct. A struct directly contains their data value on the stack. Structs don't support inheritance. The only exception, of course, is when it's inheriting from an interface. Okay, so structs can inherit from an I struct something, can inherit from an I another thing. Okay, if it's an interface, if you define an interface, I another thing. Okay, then you can a struct can inherit from it. So struct can inherit from interfaces. Structs are immutable by design, which are important to note. Which is important to note. Immutability is recommended but not enforced. Okay, structs are copied by value, meaning when you assign it, an entirely new copy of the entire struct is copied. Okay, which is why you should not use it for big, huge, complex type. Structs, unlike classes, structs has content based equality. A struct is equal to another if their contents are equal. So use structs for small, simple data. Like I think I pushed this as hard as I could when I was talking about structs. Okay, simple data holders, point coordinates. So things like this, int x, int y, very very simple data structures. No more than 64 bits. If it's actually, I would go with smaller. Okay, 32. If you can go down that much, that's why structs are not very popularly used. It's because there's not a whole lot. You should only consider it in performance when you're talking about, when you're dealing with performance. Okay, use structs for performance critical scenarios. Now, use structs when value semantics are needed. So, datetime, GUID, things like that. Do not use structs when large data is required. Okay. Next up is, of course, records that we talked about. Records can either be a reference type when you use record class, or value type when you use record struct. So what I didn't talk about is that you can actually have a record struct. So there are two types of records. Damn it. So you have string first name, string last name, and let's just leave it like this. Okay. So this is record class reference, which is a this is a record class, which is a reference type. Okay, and then we have record struct, which is a value type. So we can say public read only record structs. Didn't know you could do that, did you? Points double x double y. I'm laughing because that's what we keep doing. We keep saying, but it's important. Well, actually, you should, because this is bigger. This is 64-bit, so I'm breaking my own rules. But you get the idea. You get the idea. Records are immutable by default. Records have built-in get hash codes and to strings that ensure value-based equality. In other words, property values are compared by default. Use records as DTOs, data transfer objects, and API responses. Okay, that's precisely what they were made for. Perfect. If you're just transferring this data and you don't want it to change, use records. Okay. Use records for immutable models. Example, configuration. When you're trying to configure your connection string to your application and things like that. So records are perfect for that. State snapshot, things like that. Use records for domain events. We'll talk more about this when we get to CQRS and domain driven design. Okay? And finally, enums. Enum, short for enumerations, are name constant values underlying underlying values of enums are integer types. They have no behaviors. Let's so they have no actual behaviors. You can just say 0, 1. Well, actually, you shouldn't do that. 0, 1, 2, and so you get the idea. Okay, they have no behaviors or logic, just named integers. Use enums when you need a fixed sense set of options. Very good example would be, of course, days of the week. You don't want users to create their own days, purge day or whatever. You can replace the underlying integers from the default 0 to whatever you want. Okay, you can also replace the default integer type because these are integers by default. You can do you can replace the type to any other integral types, so it still has to be number type. Okay, byte, s byte, short. You get the idea. Use flags. Okay, use flags when combining. So if you want to use more than one of them, use flags. You can combine enum flag attributes with bitwise operations for a more verbose need. And that's it. Thanks for watching. If you enjoyed this video, please hit the like and subscribe button. Leave a comment for the algorithm gods. And let me know what you think. Thank you.